For us to first understand what Docker is, we need to first go back in time a little bit to understand what the problem was before Docker existed. Now, before Docker existed, dependencies were a nightmare. Trying to get one application to run on a different machine in a different environment was normally a pretty painful process. That machine might have a bunch of different dependencies already installed, perhaps at different versions, which means that when you install your application and you need different dependencies, you often run into dependency clashes, but also you have to install all of them, and it becomes a massive headache. Because of this, just getting something running on a new environment could take a lot of time and be quite a painful process. This is where Docker comes in to try and solve this problem. What Docker enables is by packaging everything up into a box that you can then run on any machine, meaning it doesn't actually matter where you run it because everything inside that box is isolated and will run the same no matter where. These boxes are known as containers, which are standardized units. The best way to think about it is like a shipping container. On a ship, you have tons of different containers, but the reason that they can stack so nicely is because they're all the same size. It doesn't matter what you put inside of them, the key thing is they can interlock together nicely and be transported at mass. It also allows the person putting the things in the container to decide how it's put in and make sure it's set up the way they want it to be, and then the person who is going to handle the container, in this case the operating system, can worry about handling the container in the same way it does for any other container. This ensures it runs the same anywhere, whether that's on your local development such as your laptop or on a server in the cloud. Now you might be thinking this is quite similar to virtual machines, and you'd be right. It enables the same isolation between applications that you can have with a virtual machine. But what a Docker container does to make it easier is it doesn't have to package an entire operating system inside of the container, which makes it much lighter than a virtual machine. Instead, it just shares the same host OS kernel to help it start up faster, but without having to bring the entire operating system. Instead of having an operating system, you specify a container image, which will give it all of the dependencies and the environment it needs for your application to run. Let's have a look at an example of a Docker container running and how you can make your very own. So once we've got Docker installed, which I'd recommend checking out on their website, we can test that it's working by putting docker run hello world into the terminal. And what we can see is this is going to pull a Docker image from the cloud and it's going to run. And as we can see, it was successful. What we're going to do now is create our very own Dockerfile and have it run a Python script for us with the dependencies pre-installed. So what we've got here is a simple Python script that's going to use the dependency of pandas here to be able to process a CSV file. Now, it's just a quick short script that's going to read the CSV file, get the total, and print it to the terminal. But if I try and run this right now, we're going to see that it's not going to work because pandas is not found. And this is where the container can help us by making sure that that dependency is already ready to go. So whenever we run our container, it's not going to run into any of these issues. To be able to put our Python code into a container, we need to make something called a Dockerfile. We can do this by adding Dockerfile to our directory. And then inside of it, we're going to add a number of different lines. To start with, we're going to specify which image we want to base it off. This will give us a good ground for what we're going to have in our environment. And as we're trying to run Python, using a Python image is a fantastic start. After that, we're going to specify the working directory. This is where all of the files we're going to try and run are. So it means anytime we copy anything into this container, it will be inside of this directory. This is helpful because when we try and run a command like python main.py, we want to make sure that it's running it in the same directory as the file so we don't run into any file not found problems. After that, we can then run pip install to make sure that we're getting pandas installed inside of our container. And we know that pip's going to be ready to go because we've got the Python image at the top here. But this is useful because you can run any commands like you would in the terminal. So if you need to set up your container to have the correct environment, you can either, if the image doesn't already have it, you can specify your new image, which you're creating with the container, to have these commands such as run pip install whatever. So our new container image that we're going to have here for running this in the future will have pandas pre-installed. And then the last step is we need to then take everything in our directory Docker 101 and then add it into /app. And then we can then run that main.py file from the /app folder. So all that's left now is to run a command at the end to be able to run our code. And just like that, I've now got a Docker file all ready to go that is now going to be able to set up a container with Python pre-installed add pandas on top of that using pip install, and then it can run our Python file. What we can do is now build our container into an image by using the docker build command. And when I do this, we can see that it's built our image and we're ready to now run our container. To run this now, we can just put docker run and the name of our image. And this is going to spin up a new container with a unique ID, which we can check out in a minute. And we're going to see that it's going to run. When I do this, we'll see it's going to then print out the message from our Python file, which we can just double check here. This is the one here. It's going to print out the total revenue, so we can see that it ran it successfully and it already had pandas pre-installed. So this is now a great way that I can now take this Docker image and I can run it on Linux, Windows, any other environment. So at the moment I'm running it on macOS on my local machine, but I could now run this on AWS in the cloud reliably, knowing it's going to work and not have any dependency issues. Now we can actually get Kestra to help us do this as well. So if you want to maybe automate this process and have Kestra do this on a routine for you, you can do that too. As you can see here, I've got two tasks inside of Kestra. I've got a Docker build task and a Docker run task, just like what we had inside of our local development. But this time it's going to run inside of Kestra so that we can have this run anywhere we like. And to make sure we don't run into any dependency issues, they're going to be packaged into containers. So as you can see here, we're going to use the same Dockerfile that we had previously, and we're going to kill the name of the image, my PyData app. And then when we get down to the run task, we're going to do the same thing of just telling it to run our container image, and we're going to pass it that Python file that we had. So now if I press save and execute, we're going to see that it's going to build that image just like it did on our local machine, and then it's going to run it, and we can see it successfully got the total of revenue from that Python script. So if you want to automate building and running containers, Kestra is a fantastic option for that, because you can have it run on a routine with a schedule or an event-based system such as a webhook. So if you want this to run a little bit more automated, Kestra is a fantastic choice. A slightly different approach we can use is having it still build our container like we did previously, but instead of just using the docker run command, we can actually have a Python script and then use that container image to give us the environment we need for it to run successfully. Now, as you can see, I've slightly modified the Dockerfile here to not have that command line where it's going to run the code. Instead, we're just going to create an image with the correct dependencies. Now I can now pass this to Kestra using a task runner, which allows us to run our Python code inside of a container. But to make sure it's going to run successfully, I can specify that container image to use the container image we've just built. And then underneath, I can just put my Python code exactly how I want, or I can have it automatically clone it from a Git repository, and it can then have the dependencies all set up using the container image we've automatically built. If I execute this now, we're going to see it's going to build that same container image. And once it's done that, we can then see it can run the Python code successfully. And it didn't have to do any pip install to get pandas ready. It had the environment already set up thanks to Docker. As you can see, Docker helps to simplify running an application across multiple environments. As you saw, I was able to run that Python script both in Kestra, but also locally, which shows its versatility in making sure that you can rely that your application is going to run no matter what. If you want to see Docker in more action, you can actually spin up Kestra within 60 seconds by using Docker. Check out this video here where you can learn how to do that. If you found this useful and would love to learn more about Kestra and other new technologies, then make sure to subscribe to the channel and like this video so you can see more in the future.